right, so which of these properties does lithium have a larger value than potassium? Let's go through each of these one by one. First, let's locate lithium's right there and potassium's right below it. These are both alkali metals. They're group 1 or group 1A metals. All right, first ionization energy, that refers to the energy required to remove the outermost, in this case the first outermost electron of an atom in its gaseous state. Okay, so lithium looks like that. It has two energy levels, two shells. It's got two electrons in its first energy level and then the valence electron right there. We know the electrons aren't in orbit like this, but just for illustrating this concept. Now potassium is two rows below it, two periods below it. So it's going to have four energy levels or four shells. Three of them are going to be full of electrons. And it's that fourth energy level that's going to have that one electron right there. Now you think about it. Which one of these electrons are going to be easier to pull away? Right, hopefully you're saying the potassium. That electron, that valence electron in potassium's atom is going to require less energy because it's farther away from what it's attracted to, which is the nucleus. And it has 1, 2, 3 full shells of electrons shielding it. Remember, electrons don't like each other. They're negative charges, so they repel other negative charges. Right? Whereas this one, it's only got, it's closer to the nucleus, and it's also got only two electrons shielding it. All right, so this is true. A is your answer. Now let's go on to B. B is atomic radius. Oh, by the way, the trend for first ionization energy, here is your trend, general trend, for first ionization energy is up and to the right. They generally tend to require more energy to remove their outermost electrons as you go up and to the right. Like helium, those electrons, there's no shielding going on. Those valence electrons are right in front of the action, right in front of the nucleus, where they want to be. All right, let's go on to B, atomic radius. Let me not circle that. I'll circle the answers. A is the answer. Let's look at B. Now radius is the opposite trend. Right, so as you go down and to the left, atoms get larger. Right, so knowing that lithium is there and potassium is below it, we know potassium is bigger. And we can see that in this drawing because look how much smaller lithium is versus potassium. And the simple reason is it has more shells. Potassium does. The size of lithium is smaller than potassium simply because it has more shells of electrons, and electrons take up most of the volume in an atom. This is not true. All right, let's move on to C. Trend for electronegativity, the general trend. So let me label this. This is radius. And the general trend for electronegativity is not including the noble gases because they don't really want electrons. Up and to the right until you get to fluorine is the most electronegative element on the periodic table. Electron negativity. All right, so electronegativity is the ability of an atom, let's go with like lithium. Metals don't really attract electrons well, but let's just say, because these are what we're comparing. All right, so let's say they're both sharing a pair of electrons. This would not ever be a case, a very common case. Let's say they are. All right, more typical thing would be like two nonmetals sharing electrons, but let's just say lithium, right, they're sharing, right, there's lithium's outermost electron, and then here's potassium's outermost electron, and I should have drawn this much bigger. There's 3 energy levels below it that's full of electrons, and this one's only got 1. Right, here's potassium, and they're both sharing. Well, which one's going to share? Which one of these elements are going to attract those shared pairs of electrons more? That's what electronegativity refers to. Hopefully you said it's going to be lithium is going to attract those shared electrons more. All right. Now neither of them attract electrons very well because they're metals. They don't do that very well, but in this case lithium would be. Right, it's because those electrons that are shared are closer to the nucleus of lithium versus potassium's nucleus, right? And then not only that, potassium's got all the shielding going on, as we said earlier. It's just going to be more attracted if you had to choose between the two toward lithium. So this one's also true. C is also correct. Lithium has a higher electronegativity than potassium. Now finally, ionic radius, just as we did in atomic radius, it's not going to be true because ionic radii, right, when metals lose electrons, these are both metals, so we have to apply. They'll typically lose electrons, metals will, and they'll form what we call cations. Now when this electron leaves, this whole energy level, that whole shell doesn't exist anymore, right? When that valence electron leaves, right, that's how we get an ion. That's why I'm doing this, right? That whole shell doesn't exist anymore. Now, without that shell and without that shell, lithium is still way smaller because potassium has 3 full shells of electrons. 1, 2, 3. Lithium is smaller. So your answer is A and C.